In this episode, we begin with a simple idea that turns out to matter a great deal in both operations and auditing. Every information system is made up of parts, and those parts have to work together in a dependable way for the business to function. When people first hear the phrase information technology, IT components, they sometimes imagine a pile of hardware in a server room or a few pieces of software on a screen. The reality is broader and more connected than that. IT components include the physical devices, the software layers, the communication paths, the data structures, and the supporting services that together allow an organization to process information and deliver business results. For someone preparing for the Certified Information Systems Auditor (CISA) certification, this topic matters because systems do not fail or succeed as a single object. They succeed or fail through the behavior of individual components and the relationships between them. Once you understand those pieces and how they depend on one another, the larger ideas in operations, resilience, and control become much easier to understand. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A component is simply a part of a larger system that performs a function and contributes to an overall outcome. That sounds basic, but it is a useful definition because it keeps the discussion grounded. A component can be something physical, like a server, laptop, or storage device, but it can also be something logical, like an application, a database, or an authentication service. In the real world, businesses rely on combinations of these pieces rather than on isolated tools. A payroll system, for example, may depend on user devices, a network path, an application server, a database, storage, identity services, backup processes, and monitoring tools, all working together in the right sequence. If one part is weak or unavailable, the whole service may be slowed, disrupted, or made less trustworthy. That is why auditors care about components individually and collectively. Understanding the pieces helps reveal where risk sits, where controls matter most, and where a small failure could create a much larger business problem. One major category of IT components is hardware, which refers to the physical equipment that supports computing and communication. Hardware includes servers, desktop computers, laptops, mobile devices, storage arrays, network equipment, backup devices, and other physical assets that help data move, process, and remain available. For beginners, hardware can feel old-fashioned compared with cloud discussions or software topics. But physical infrastructure still matters because all digital activity depends on some underlying equipment somewhere. Even when a business uses hosted or external services, there is still hardware supporting those services behind the scenes. Hardware components have limits, wear out over time, require maintenance, and can fail suddenly or gradually. Their capacity, condition, and configuration influence performance and resilience. A system may have excellent software design, yet still experience problems because a storage device is overloaded, a network switch is unstable, or a server does not have enough processing power for the demand placed on it. Hardware is not the whole story, but it remains one of the most visible and essential building blocks. Within hardware, computing devices deserve special attention because they carry out the instructions that make applications and services function. A server usually provides shared processing for many users or systems, while endpoints such as laptops and desktops allow individuals to interact with business applications directly. Mobile devices add flexibility, but they also introduce operational and security considerations because they connect from different places and under different conditions. Processing components such as the Central Processing Unit, CPU, and memory components such as Random Access Memory, RAM, influence how quickly a device can perform work, handle concurrent activity, and respond under pressure. A beginner does not need to become a hardware engineer to understand the high-level point. If a device cannot process instructions efficiently, store active information temporarily, or stay stable under load, then the user experience and the reliability of the business service will suffer. From an audit perspective, the question is not whether every device is powerful in the abstract. It is whether the computing environment is appropriate for the business need and managed in a way that supports dependable operation. Another major category is software, which gives hardware useful purpose by telling it what to do and how to do it. Software ranges from operating environments and system utilities to business applications and specialized services. Without software, a device is simply capable equipment with no business direction. A useful beginner distinction is between system software and application software. System software includes the foundational layers that help hardware operate and provide a platform for other programs, while application software performs tasks the business or user directly cares about, such as accounting, human resources, sales processing, collaboration, or reporting. The operating system, OS, is one of the most important software components because it helps manage resources, coordinate activity, and provide the environment where other programs run. When an auditor thinks about software components, the concern is not only whether the software performs a task, it is also whether it is supported, configured properly, patched appropriately, compatible with surrounding components, and controlled in a way that reduces operational and security risk. Applications deserve their own attention because they are often the components most visible to the business. An application is where users enter information, review results, approve transactions, generate reports, or trigger workflows that support daily operations. To a new learner, an application may seem like the system itself, but in most cases it is only one layer in a much broader arrangement. An application depends on other components for identity, connectivity, processing, storage, logging, and recovery. If any of those supporting parts are weak, the application may appear unstable even when its own code is not the main problem. This matters in audit because business complaints often focus on the application experience, while the real root cause may live elsewhere. A slow report might be caused by database design, network delay, or server capacity rather than by the report screen itself. A careful understanding of IT components helps separate symptoms from causes. That way, operational issues can be evaluated more accurately, and control questions can be aimed at the part of the environment where the real risk sits. Networks are another core set of IT components because they allow systems, users, and services to communicate with one another. A network includes the paths and devices that carry data between endpoints, servers, storage, applications, and external resources. Beginners often think of the network as simply the internet or the office connection, but the idea is broader than that. Networks make it possible for a user to reach an application, for an application to reach a database, for systems to send logs, and for backups to move to protected locations. If the network is unavailable, congested, or poorly segmented, many other components may still exist and still be healthy, yet the business service can appear broken. That is one reason networks matter so much in operations and resilience. They are connective tissue rather than isolated equipment. From an audit perspective, network components raise important questions about availability, access control, monitoring, redundancy, and the degree to which communication paths support or weaken the organization's ability to maintain secure and stable services. Data storage is another foundational area because information must exist somewhere in a form the organization can retrieve, protect, and rely upon. Storage components include local drives, shared storage systems, cloud-based storage services, and backup repositories, among others. A beginner may think of storage as simple digital space, but from an operational viewpoint, it is more than capacity. Storage affects speed, availability, durability, and recovery. If storage is slow, applications may lag. If storage is full, transactions may fail or jobs may stop. If storage is poorly protected, the organization may lose important information or expose sensitive data. Storage also matters for resilience because the ability to restore operations often depends on whether reliable copies of critical data exist and can be recovered in time. Auditors look at storage components not only as containers for information, but as controlled resources that should support retention, confidentiality, integrity, and availability. A business may think it has protected its information, yet if the storage architecture is fragile or unmanaged, that confidence may be weaker than it appears. Closely related to storage are databases, which organize information so that applications can use it consistently and efficiently. A database is more than a file full of records. It is a structured collection of data designed to support retrieval, update, reporting, and control. Many important business systems depend on a database management system, DBMS, to handle these tasks, enforce relationships, and support transactions in an orderly manner. For beginners, it helps to think of a database as the carefully arranged memory of a business process rather than as loose information scattered around a folder. Customer accounts, payroll records, orders, inventory values, and access permissions often depend on database components functioning correctly. If the database is inaccurate, unavailable, or poorly secured, many applications can be affected at once. In audit, databases matter because they sit at the center of data integrity questions. When information is entered, changed, deleted, or reported, the structure and control of the database can strongly influence whether the result is trustworthy, complete, and useful to the organization. Identity and access components are also essential because systems should know who is requesting access and what that person or service is allowed to do. These components may include directories, authentication services, authorization rules, access groups, and supporting logging mechanisms. To a beginner, access control sometimes sounds like a single password prompt, but the actual environment is often much more layered. The organization needs a dependable way to recognize users, connect them to roles, and apply permissions in a manner that supports both business productivity and control expectations. If identity components fail, users may be locked out of necessary systems, or worse, they may gain access that should have been restricted. This makes such components central to both operations and security. An application can be perfectly available, yet still unusable if users cannot authenticate properly. From a CISA perspective, these components matter because access management affects confidentiality, accountability, segregation of duties, and the organization's ability to prove that activities were performed by the right parties under the right authority. Supporting services often receive less attention from beginners, yet they are critical because they make the larger environment stable and manageable. These services may include monitoring tools, time synchronization, job schedulers, logging services, backup agents, update services, and communication tools that help administrators and applications function consistently. The business may never mention these components by name, but their absence is often felt quickly when things go wrong. For example, poor logging can make it difficult to investigate incidents. Weak time coordination can confuse event analysis, and missing monitoring can allow failures to spread before anyone notices. These supporting components are a reminder that not every important part of an information system is visible to end users. Many of the most valuable components are the ones that maintain order in the background. Auditors care about these services because control depends heavily on visibility and consistency. A business cannot manage what it cannot see well, and it cannot respond effectively if the tools that provide insight into the environment are unreliable or incomplete. Modern environments also include virtual and cloud-based components, which can make systems more flexible but also more abstract. Virtualization allows one physical environment to support multiple logical systems, while cloud services shift some infrastructure responsibility to external providers and service models. A beginner might think these changes make physical components less relevant, but they really change how the components are packaged, managed, and delivered rather than removing the need for them altogether. There is still computing, storage, networking, identity, monitoring, and data handling involved. The difference is that the organization may no longer own or directly operate every part. This matters in audit because responsibility can become less visible. Management may assume a provider handles everything, while in reality some controls remain with the customer, especially around access, configuration, data governance, and monitoring. Understanding IT components in modern environments means learning to see beyond the location of the technology and focus on the function, dependency, and accountability of each part. Outsourcing a component changes oversight needs, but it does not eliminate risk. One of the most important lessons in this topic is that components do not operate independently. They form chains of dependency, and those chains are often the key to understanding operational risk. A user device depends on connectivity. Connectivity depends on network components. The application depends on servers and software platforms. The application also depends on a database, and the database depends on storage and recovery processes. If one part fails, the user may only notice that a screen does not load, but the real issue may sit several layers deeper. This is why root cause analysis and architectural awareness matter so much in operations and audit. Beginners often focus on the visible symptom because that is what the business experiences first. A more mature view asks which supporting components make that visible function possible and which of those could reasonably explain the observed issue. CISA expects this kind of thinking because effective control review depends on understanding relationships, not just isolated assets. A strong component may still participate in a weak service if the surrounding dependencies are poorly managed. From an audit perspective, IT components are examined through questions of inventory, ownership, configuration, support, control, and resilience. The auditor wants to know whether the organization understands what components it has, what business services depend on them, who is responsible for them, and how they are protected and maintained over time. If components are unknown, unsupported, or configured inconsistently, the organization may be carrying more risk than leadership realizes. A component does not need to fail dramatically to become a problem. It may simply be outdated, poorly documented, dependent on a single person, or missing from resilience planning. Those conditions can weaken the entire service even before an incident occurs. This is why component awareness supports so many other audit topics, including asset management, change control, security, incident response, and business continuity. You cannot manage, secure, or recover something well if you do not clearly understand the pieces involved and the role each piece plays in delivering value to the business. By the time we reach the end of this discussion, the main idea should feel steady and practical. IT components are the individual parts that make information systems function, and understanding them helps explain how technology supports the business in the real world. Hardware, software, applications, networks, storage, databases, identity services, supporting tools, and modern virtual or cloud-based elements all contribute to daily operations and long-term resilience. None of these components matters only in isolation. Their importance comes from how they interact, what they enable, and how failure or weakness in one area can affect the service as a whole. For exam preparation, remember that a strong CISA mindset does not stop at the surface of a working application. It asks what components sit underneath that experience, how they depend on one another, whether they are controlled and supported properly, and what business risk appears if they do not perform as expected. That way of thinking turns a long list of technology parts into something much more useful, a clear view of how systems actually work and how they should be governed.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.